Hello, geometry. So today we are going to explore further with triangle congruency. So far, we've looked at three pairs of congruent parts. So the side worked, and side angle side also worked as triangle congruency reasons. Today we're going to start with trying angle, angle, angle. So if I'm only given three angles of a triangle and then have three congruent angles of another triangle, do those triangles have to be the same size or congruent to each other? So looking here, we're going to draw ourselves a triangle with 60 degrees, 60 degrees, and 60 degrees. So this makes an equiangular or equilateral triangle. Okay, so I'm going to draw another one. I thought I was going to be able to copy this and then size it up for you, but it's not working. So I'm going to draw another one for you. But this time, it's going to be proportional to the first one, but very obviously not the same size. So this could also be a triangle with three 60-degree angles. And they are very obviously not congruent to each other. They are not the same size triangles, but they have the same angle measures. So what does that mean about angle, angle, angle as a congruence postulate? Does having just three angles congruent to three other angles make the triangles congruent? No, it does not. Okay, so take a pause and try to explain that in your own words. Okay, welcome back. So we'll go through those explanations in class. Exploring angle, side, angle. So in this case, notice that the S in the name is literally between the two A's. So this is what's called an included side. So the side is included in between the two angles or is attached to both angles. So we're going to draw a triangle with angle measures of 50 degrees and 60 degrees, but those have to be attached to, or the side needs to be included, and that side is going to be 1 inch long. Okay, so starting out, I'm going to draw ourselves just a side, and I've discovered that I need it to be straight up and down, or else the protractor doesn't work so well. So let's try that again. Okay, so now you could measure this. We're going to just use a scale so that we're assuming this is 1 inch. And then we're going to construct a 50-degree angle on one end and a 60-degree angle on the other end so that this side is attached to both angles or is included between the two angles. Okay, so let's get a protractor and measure out 50-degree angle to start. So you line up the protractor and then use a measurement of 50 degrees is right here. Try to make this as accurate as possible with this thing working, of course. Okay. Seriously going to scream. Okay, there we go. So there's the 50-degree angle. It's a little bit off, but we're going to deal with that. And then I'm going to move this protractor over, and we're going to make a 60-degree angle on the other end. Okay, so 60-degree angle, here's the 60. And again, it's so going to work at any moment here. Okay, well, I give up. Okay, so 60-degree angle is going to go right there from this point down anytime. There we go. So that is a 60-degree angle. And you have to imagine that when you draw the 50 and when you draw the 60, there's really only one point where those have to intersect. So when you're given angle, side, angle, there is only one way to make that triangle. So all other triangles will be congruent to this one. So does angle, side, angle work for congruency? Yes, it does. And again, please take a minute and try to explain that in your own words. Okay, our next one, angle, angle, side. So notice that here the side is not included or between the two angles. So what that means is, again, we start with a side. And again, I'm going to write that that's 1 inch. Okay, this time we are going to have the 50-degree angle on one end, but then the 60-degree angle cannot be on the other end. Otherwise, that would be the angle, side, angle. So let's see. So there's the 50 degrees. And it's slightly off, but I'm sure will be fine. 60 degrees would come up from this end, right? But we have no idea where to put it in order to have that ray exactly intersect here. So what we are going to do instead is we are going to use the Triangle Sum Theorem. And that states that three angles of a triangle have to add up to 300 or 180 degrees. So if I have 50 and I have the 60, I have one other angle, and those have to add up to 180. So since I don't know where to put the 60-degree angle up here in order to have angle, angle, side, I am going to actually calculate what this angle should be, which if you do the calculation should be 70 degrees. And I'm going to put the 70 over here, which guarantees this is 60 degrees. Okay, so we're going to measure out 70 degrees over here. I don't really trust this to work well, so I'm just going to draw it in there. But imagine that we figured out 70-degree angle with the protractor. So that's 70, and then this would have to be 60 by the Triangle Sum Theorem. Okay, now a lot of people have trouble with determining whether it's angle, side, angle, or angle, angle, side. So let me just highlight a couple of things to know. So we were given a 50 degree, a 60 degree, and then a 1 inch side. So here's the 1 inch side. Here's my 50 degree angle. And then notice for angle, angle, side, so I'm doing angle, angle, side in this triangle, the 60 degree angle is across from the side that's given. Or in other words, the side is not connected to both of the angles. That's angle, angle, side. Previously, here we are given this 1 inch side. The 50 degrees is still here, but notice where the 60 degrees is. It's attached to the side that's given. So this is angle, side, angle. Okay. But anyway, so angle, angle, side does work, yes. And then I want you to, again, try to explain why in your own words. Okay, welcome back. So these are some examples of things you'll see in your homework. So what you want to do is look for things that are marked in the picture and then mark other congruencies you know from the given information. So example, this one has parallel lines, so I can do alternate interior angles in this picture. So I would know angle P is congruent to angle S because there's a Z right here, but there's another Z going the other direction as well. So I would know that angle T is congruent to angle R. So right off the bat, we're going to give the reason that these triangles are congruent. So I have an angle, I have a side, and I have an angle, and the side is between or connected to both angles. So that is going to be angle, side, angle. And that officially is a postulate. Okay, doing the congruency statement, you just got to make sure your letters are matching up. So I can do the first triangle any order I want to. So P, R, Q, let's go with. And then if I start with P, I have to start with S. Those are marked as congruent. And then I went to R, so then I have to go to T, and then end with the Q. So this is an angle side angle. Next one. So over here, I'm given right angles, which I can prove to be congruent. I'm given a couple of sides here. And then from this picture, I can also mark congruent vertical angles. So this one, notice the side is not connected to both angles. So this is going to be angle, angle, side. And that is officially a theorem that you can prove using the Triangle Sum Theorem. And then our congruency statement, again, just be consistent. G, F, H, we'll go with start, would be congruent to. If I start with G, I'm going to start with I, and then J, H. Okay, so if you were in traditional geometry, you actually can stop. The next part would be optional for you, but advanced geometry, you have to continue. So HL is the last reason. An HL theorem, you are given two right triangles. And then if the hypotenuse and leg of one triangle are congruent to the hypotenuse and leg of another, then the triangles are congruent. This is not in the advanced geometry book, but you do have to know it. Okay, this is called the HL or hypotenuse leg triangle congruency theorem. So I'm just going to talk you through the proof of this. It's actually a pretty cool one. So here, notice that the triangles you're given right angles, making them right triangles. You're given the hypotenuse. So this would be the hypotenuse, and this would be another hypotenuse, congruent, and each a leg. So these are a leg that are congruent. So this is a picture marked with hypotenuse leg. Now, if I squeeze those triangles together, it makes one big isosceles triangle. So these two congruent sides squeeze together and match up. The right angles match up to form a line. And then the hypotenuse become the two congruent sides of this bigger isosceles triangle. So I'm just going to talk you through it instead of writing it all out. But basically, once you squeeze these triangles back together and you have that isosceles triangle, so again, highlighting, this is the isosceles triangle. What I can do is then use the isosceles triangle theorem to state that angle G is congruent to angle I. And because I have those base angles congruent, and I have the right angles which are congruent, and then I have another side, these triangles can be proven congruent using angle, angle, side. Okay, so in the end, at the end of our proof here, we can say triangle HGJ is congruent to triangle, so HGJ and HIJ, IJ. And the reason why they are congruent is because we used angle, angle, side theorem. So again, we used a previously proven theorem to prove this theorem. So now I can use it. And if I have a right triangle, a hypotenuse and leg, then the triangles are congruent. So here's a couple examples. So in this picture, I have a right angle. I can assume or prove pretty easily that is also a right angle. And then I have the hypotenuse congruent and the legs congruent. So these triangles are congruent by the HL theorem. And again, your triangle congruence, you just need to be consistent. So if I said A, B, C, A to B to C, I would go E, D, F. Okay, now a big misconception is if you see right angles, then you automatically use HL. That is not true. You can also use right angles just as congruent angles. So this is one we did above. Remember, we'd used vertical angles, and then I had two angles that are congruent and the non-included side. So this is actually angle, angle, side. So just be very careful. Do not assume that a right angle automatically means HL, because it doesn't. Okay, good job. See you next time.